The strongest Western Pacific typhoon of the 2026 season is intensifying east of the Philippines right now, and it is forecast to make its closest approach to Okinawa on Monday and Tuesday. Typhoon Number 6 is currently at 998 hectopascals. By Sunday, it is forecast to be at 950. By Monday, it will be threatening 25 million people across the southern third of Japan. In the next 20 minutes, I will tell you what the 4 forecasting agencies are seeing, what the warm pool underneath the storm has to do with the intensification, and what to watch for over the next 72 hours. Yesterday afternoon, Japan Standard Time, the Japan Meteorological Agency upgraded its tracking of a tropical system east of the Philippines and gave it the designation Typhoon Number 6. The international name is Chanmii. The United States Military Joint Typhoon Warning Center designates it 06 West and uses the alternate name Jangmi. The Philippine National Meteorological Service calls it Domeng, 1 storm, 4 names. 4 governmental authorities all watching the same low-pressure systems spin up over the same patch of ocean, and all of them coming to the same forecast conclusion. Here are the numbers as of yesterday's bulletins. Per the Joint Typhoon Warning Center, fix at 03 Universal Time, the system was located approximately 430 kilometers northwest of Yap Island, in the Federated States of Micronesia. It was moving toward the northwest at approximately 24 kilometers per hour. Sustained winds were approximately 56 kilometers per hour. Gusts were running up to 75 kilometers per hour. Per the JMA bulletin at 1500 Japan Standard Time, central pressure was 998 hectopascals, maximum sustained winds were 18 meters per second, and maximum gusts were 25 meters per second. Read those numbers in isolation, and the storm looks unremarkable. 18 meters per second is about 40 miles per hour, which is the tropical storm threshold on every major intensity scale. 998 hectopascals is barely below standard atmospheric pressure at sea level. A casual reading would call this a moderate tropical depression that just crossed into tropical storm intensity. Hundreds of miles from anything that matters. That reading is wrong. What makes it wrong is not the current numbers. It is what the forecast says the current numbers are about to become. The JMA forecast trajectory for Typhoon Number 6 places the storm in 3 sequentially intensifying categories over the next 96 hours. By 1500 Japan Standard Time on Saturday, May 30th, the storm is forecast to reach the JMA Strong category, sustained winds of 33 to 43 meters per second, equivalent to Category 1 to low Category 2 on the Saffir-Simpson scale. By 1500 Japan Standard Time on Sunday, May 31st, the storm is forecast to reach the JMA Very Strong category. Sustained winds of 44 to 53 meters per second, equivalent to Category 2 to mid-Category 3 Saffir-Simpson. The forecast central pressure at peak intensity is approximately 950 hectopascals. That is a 48 hectopascal pressure drop in 72 hours. 48 hectopascals in 72 hours sits inside the operational threshold for rapid intensification. The Joint Typhoon Warning Center bulletin uses the phrase rapid intensification explicitly to describe the 2 to 3 day window. The JTWC peak intensity forecast is approximately 90 knots, 165 kilometers per hour, reached at the 4-day mark. Rapid intensification is the single forecast scenario that breaks public safety planning. A storm that intensifies on a gradual schedule gives the public, local governments, airlines, and disaster response infrastructure time to position. A storm that intensifies rapidly can arrive at landfall a full category stronger than the official forecast said it would. The lead time available to update warnings, escalate evacuation orders, and ground commercial transportation compresses correspondingly. The mechanism of rapid intensification is a self-amplifying feedback loop. Low pressure at the center pulls in warm, moist surface air. The inflowing air rises through the storm's core. Water vapor condenses and releases latent heat into the column. That heat warms the core, deepens the surface low, accelerates the inflow, and delivers more warm, moist air to the system. The loop can only be broken by external constraints: vertical wind shear, dry air intrusion, or transit over cooler water. None of those constraints are present in the forecast environment between the storm's current position and the waters southeast of Okinawa. The forecast closest approach to Okinawa, Honshu, Okinawa's main island, is currently set between Monday, June 1st and Tuesday, June 2nd. At that point, the storm is forecast to have already passed its peak intensity and to be back in the JMA Strong category, with sustained winds of approximately 40 meters per second and central pressure of approximately 950 hectopascals. 40 meters per second is approximately 89 miles per hour, Category 1 on the Saffir-Simpson scale, That is the wind speed at which roof tiles strip off buildings, outdoor signage rips loose, and the storm surge along a low-lying coast can exceed the height of a single-story building. The JMA bulletin issued yesterday afternoon was specific in a way that bureaucratic Japanese weather bulletins rarely are. It named regions. It named a wind threshold. It named a date window. The translated language is precise: violent winds of 25 meters per second or more, possible across Okinawa, Kyushu, Shikoku, and the Chugoku region between June 1st and June 2nd. 25 meters per second is approximately 56 miles per hour. In international convention, sustained winds at that speed are the boundary above which structural damage begins to occur at scale, transportation infrastructure starts to fail, and the public safety calculus tips from monitor and prepare to shelter in place. Walk through the geography of the warning zone. Okinawa Prefecture sits at the southern end of the Japanese archipelago, with a population of approximately 1.46 million people, and the major United States military installations at Kadena Air Base and Marine Corps Air Station Futenma. The Amami Island chain to the immediate north holds approximately 70,000 people across Amami, Oshima, and the smaller satellite islands. Kyushu, the southernmost of Japan's 4 main islands, has a population of approximately 12.7 million. Shikoku has a population of approximately 3.6 million. The Chugoku region of western Honshu, encompassing Hiroshima, Yamaguchi, Okayama, Shimane, and Tottori prefectures, has a population of approximately 7.1 million. Add the numbers. The total population in the JMA named warning zone for the June 1st to June 2nd window is approximately 25 million people. That is roughly 20% of the Japanese national population. 1 in 5 Japanese citizens, sitting under a forecast violent wind footprint, with a storm 3 to 4 days away from impact. And if the forecast track shifts even 50 kilometers further east, which is well within standard cone uncertainty at the 3-day window, the warning footprint expands to include the Kii Peninsula in Wakayama and Mie prefectures, the Kansai region around Osaka and Kobe with its roughly 20 million metropolitan population, and potentially the western suburbs of Tokyo. A 50-kilometer track shift could push the exposure number to 60 million people, nearly half the Japanese national population. There is one additional piece of the JMA bulletin that the Japanese public is paying close attention to. The agency issued an advisory about the formation potential of a linear precipitation band, Senju Koshuitai in Japanese, in the Amami region as the storm approaches. Linear precipitation bands form when convective cells align along a stationary moisture convergence boundary and train rain over the same ground for many hours. They can produce rainfall totals exceeding 500 millimeters in 24 hours over a 50 by 100 kilometer footprint. The August 2021 Western Japan flooding, the July 2020 Kumamoto disaster, and the July 2018 Western Japan floods all featured linear precipitation bands as the proximate cause of the most catastrophic local impacts. When JMA flags formation potential, the public knows what it means, and the public responds. The reason the Japanese language social media reaction to yesterday's bulletin was so intense: the most circulated JMA forecast cone graphic accumulated approximately 1.9 million views within hours of release, and a follow-up post pairing 2 Winfield model panels accumulated approximately 1.1 million additional views with a caption that translates to "The predictions are getting worse and worse," is that the forecast has, in fact, been getting worse. Successive 12-hour forecast updates from JMA, the European Center for Medium-Range Weather Forecasts, and the U.S. Global Forecast System over the past 48 hours have all shifted the track northward and eastward, and the intensity at peak upward across multiple consecutive runs. Earlier in the week, the storm was forecast to stay generally west of the Japanese archipelago and dissipate over the South China Sea. By yesterday afternoon, the forecast had the storm tracking through the Ryukyu chain at strong intensity with potential mainland Japan impact in Kyushu, Shikoku, and Honshu. When a forecast cone moves randomly across update cycles, north on one run, south on the next, the noise is operational uncertainty. When a forecast cone moves in the same direction across multiple successive cycles, the noise is signal. It usually means the models are catching up to an underlying environmental change. The pattern with Typhoon Number 6 is unmistakable: northward, eastward, and stronger, run after run. A second technical detail is worth noting. The intensity shift across recent model cycles has been larger than the track shift. The track has moved by 50 to 100 kilometers, which is within standard cone uncertainty. The intensity at peak has moved by roughly 1 full intensity class, from the upper boundary of strong to the middle of very strong. Larger intensity shifts than track shifts is the signature of an underlying ocean change rather than an atmospheric one. The warm pool is holding more thermal energy than the models had previously characterized, and the model is catching up. There is one more layer to the forecast confidence picture. 4 independent forecasting architectures have now converged on the same trajectory. The JMA Global Spectral Model, the Joint Typhoon Warning Center's blend of GFS, ECMWF, and Navy NavGem, the European Center's integrated forecasting system, and the Google DeepMind GenCast artificial intelligence ensemble, which trains on entirely different mathematical principles than the traditional numerical weather prediction models. 3 governmental authorities, 3 traditional architectures, 1 AI system, all converging on the same answer. That is about as strong a forecast signal as operational meteorology can produce 3 days out from impact. To understand why Typhoon Number 6 is forecast to intensify the way it is forecast to intensify, you have to look at the water underneath it. Tropical cyclones are heat engines. They convert warm, moist surface air into mechanical energy through latent heat release. The fuel is sea surface temperature. The waters east of the Philippines along Typhoon Chanmii's projected track are holding 29 to 30 degrees Celsius. The Windy.com summary published yesterday named this explicitly as one of the favorable conditions driving the intensification forecast. 29 to 30 degrees Celsius is well above the 28-degree operational threshold for major tropical cyclone activity, and it is in the territory where rapid intensification becomes substantially more likely. What is more significant than the surface temperature itself is the structure of the warm water beneath the surface. Tropical cyclone intensification is constrained not just by sea surface temperature, but by the thickness of the warm water layer above the thermocline. When a typhoon moves over the ocean, its surface winds drive vertical mixing, pulling cooler water from below up to the surface. This upwelling normally caps intensification. As the storm churns the water beneath it, it brings cooler water up and reduces the local heat supply. For slow-moving storms, and Typhoon Number 6 is characterized as slow-moving in the JMA bulletin, upwelling becomes a meaningful constraint, except when the warm water layer is unusually thick. If the water is 28 degrees Celsius not just at the surface, but down to 50 meters of depth, the surface winds can churn the upper ocean as much as they want, and the water that comes up will still be 28 degrees. The upwelling mechanism that normally caps intensification stops working. The storm's heat engine continues to receive full fuel input regardless of how much surface mixing it generates. That is the structural condition currently in place along Typhoon Chanmii's projected track. The waters east of the Philippines are holding 28-degree water down to approximately 50 meters depth across a broad area. The storm can spin up over that water, churn it to any degree its wind field demands, and the heat supply does not run out. The Windy.com summary also explicitly noted that the vertical wind shear environment is weaker than climatology, the second favorable condition for intensification. Low wind shear allows the storm's vertical structure to remain organized, which is essential for the latent heat release feedback loop to operate efficiently. Warm water plus low shear is the textbook recipe for rapid intensification. Both ingredients are present. The warm pool conditions driving Typhoon. Number 6's forecast trajectory are not random. They are linked to a broader large-scale climate signal that has been in transition for the past 6 months. The U.S. Climate Prediction Center declared an El Niño watch in May 2026. The watch placed the probability of El Niño onset by the May, June, July season at between 82 and 98%, depending on the specific ensemble product, and the probability of persistence into the 2026 to 2027 winter at 96%. The China National Climate Center, in an April and May 2026 analysis, declared that the equatorial, central, and eastern Pacific had already entered El Niño conditions, with a moderate intensity event expected by winter and a peak sea surface temperature anomaly forecast of 2.0 to 2.5 degrees Celsius. The threshold for what is called Super El Niño is a peak anomaly of plus 2 degrees Celsius. China's forecast places the developing 2026 event at the lower bound of Super El Niño territory. In El Niño phases, the equatorial Pacific warm pool shifts eastward, the trade winds weaken, vertical wind shear over the western Pacific decreases, and the storms that do form tend to have longer overwater trajectories with more time to intensify. El Niño years often produce fewer total western Pacific typhoons than climatology, but the storms that do form tend to be more intense. The peer-reviewed literature documents that this pattern has been intensifying for decades. A 2018 study by May and Tsai, published in Nature Geoscience, documented 12 to 15% intensification of landfalling western Pacific typhoons since the late 1970s, with the proportion reaching Category 4 or 5 intensity doubling, and in some subregions, tripling. A 2024 assessment by Knutson and colleagues, published in the Bulletin of the American Meteorological Society and authored by a multi-agency team, found medium to high confidence that the proportion of Western Pacific tropical cyclones reaching Category 3 through Category 5, intensity has increased with warm pool sea surface temperatures as the dominant driver. A 2023 paper by Lee and colleagues in Science Advances documented something even more specific. The latitude of peak intensity for Western Pacific tropical cyclones has shifted poleward at approximately 53 kilometers per decade since 1980. Storms now reach their strongest intensity at higher latitudes than they did a generation ago, meaning closer to Japanese territory. Typhoon Number 6 is the first major storm of the 2026 season to test the developing El Niño regime, the forecast trajectory, rapid intensification over warm pool waters, peak intensity in the very strong category. Curvature east of the warm pool's eastern edge is consistent with the canonical El Niño-era Western Pacific typhoon track. Whether this storm is the first of many that will follow the same template across the rest of the season, or whether it is an early outlier, is the question that only the season's full statistical record will answer. Tying this back to the storm itself, Typhoon Chanmii is doing what storms in this configuration now do. It is not exceptional given the underlying state of the ocean. It is what physics says happens when this configuration is in place, and physics is currently doing a lot. Japan's typhoon response infrastructure is among the most sophisticated in the world. The Japan Meteorological Agency operates approximately 1,300 surface weather stations, several dozen weather radars, and a constellation of satellites providing real-time imagery of the Western Pacific Basin. The agency's continuously updated warning system issues bulletins at 6-hour intervals during normal weather and at 1-hour intervals during active tropical cyclone events. In early 2026, the JMA deployed a revamped disaster alert system that significantly upgraded the resolution of its warning output. The previous system issued bulletins at the prefectural level. The new system issues bulletins at the city block level with a 500-meter spatial resolution and a tiered warning hierarchy that escalates as a threat closes the distance to populated territory. The tiers run from advisory through warning, through emergency warning, through Tokubetsu Keihu, special emergency warning, which is reserved for once-in-a-generation events that historical records suggest occur with a frequency of perhaps once every 50 years at a given location. When a Tokubetsu Keihu is issued, automatic legal authorities at the municipal level kick in. Evacuation orders can be made mandatory, public transportation can be suspended, and outdoor activities become subject to enforcement action. The system delivers warnings through multiple parallel channels. Broadcast media is legally required to interrupt programming for special emergency warnings. The J-Alert mobile push notification system targets specific geographic areas down to the city level. Municipal loudspeaker networks broadcast warnings in real time to populations not near a television or phone. The JMA web portal updates continuously. This infrastructure is the reason Japan, despite being one of the most typhoon-exposed populated countries in the world, has dramatically lower per capita fatality rates from typhoon impacts than most countries with comparable storm exposure. Typhoon Jebi in 2018, the costliest typhoon in Japanese history with damage estimates exceeding $15 billion, killed 17 people. Typhoon Hagibis in 2019, with comparable damage estimates and catastrophic flooding across central Honshu, killed approximately 100. The historical record before the modern warning system included events like the 1959 Vera typhoon, also known as Ise, which killed more than 5,000 people, and the 1934 Moroto typhoon, which killed more than 3,000. The system saves lives. The system has one structural limit, and it matters for Typhoon Number 6 specifically. The minimum lead time required for full institutional response, local governments issuing evacuation orders, airlines grounding flights, hospitals preparing for surge demand, utilities prepositioning repair crews, is typically 24 to 36 hours. The current lead time for Typhoon Chanmii's closest approach to Okinawa is approximately 72 to 96 hours. That is comfortable. That is enough time for everything the system is designed to do. But if rapid intensification arrives faster than forecast, the effective lead time compresses. A storm forecast to reach very strong intensity by Sunday could plausibly reach very strong intensity by Saturday if the rapid intensification window opens sooner than expected. A storm forecast to weaken to strong intensity by Okinawa landfall could plausibly maintain very strong intensity at landfall if the cooler waters east of the warm pool fail to arrive on schedule. The forecast updates will catch the change. The institutional response window will not move faster than logistics allow. Tying this back to the storm itself, Japan is going to do everything any country with the warning architecture in place could possibly do. Whether the warning system has the lead time to fully execute depends on whether Typhoon Number 6 cooperates with the forecast schedule. That is the question the next 48 hours will answer. Any major weather event triggers alternative framing currents in public discussion, and Typhoon Number 6 is no exception. The dominant viral claim circulating online right now is that the storm is being steered toward Japan by HARP, weather modification, or coordinated state actors. The claim deserves a direct engagement on substantive grounds, not a dismissal. The energy budget argument is decisive. A typhoon at very strong intensity releases approximately 6 quintillion joules of energy per day in latent heat release alone. That is 6, followed by 18 zeros. The HARP facility in Alaska, which is the most cited single weather modification target in this framing, transmits at 3.6 megawatts at peak operation. Running HARP continuously for an entire day delivers about 300 billion joules. The ratio between the typhoon's daily energy output and HARP's maximum daily output is approximately 20 million to 1, a 7 order of magnitude gap. That is not a small gap. Cloud seeding can enhance local precipitation in existing clouds by 5 to 15% under optimal conditions, but it cannot generate the rotation, the warm core structure, the closed pressure gradient, or the latent heat exchange that defines a tropical cyclone. Steering a tropical cyclone is not within the technological capability of any state actor in 2026. The coordinated falsification claim that JMA, JTWC, and the European Center are inflating the forecast is similarly unsupportable on structural grounds. 3 governmental authorities, 3 independent forecast architectures, 3 observation network feeds, 3 language regions, plus the Google DeepMind GenCast AI system, which was trained on entirely different mathematical principles than the traditional models. Coordinated falsification across that many independent systems is a logistical impossibility on the available evidence. The reason all 4 are showing similar forecasts is not coordination. It is that the underlying physics is the same, the underlying data is the same. Given the same input, independent forecast systems converge on similar outputs. The storm exists because the warm pool is warm. The storm tracks the way it does because the subtropical Pacific high-pressure pattern steers it. The forecast updates every 6 hours and is publicly available from every agency. The math is on the public record, and it does not require anyone to be lying about anything for the threat to be real. The forecast for Typhoon Number 6 will resolve in 3 specific windows over the coming 4 days, and each window will answer a different question. The first window is the vortex alignment window, the next 24 hours. The JTWC bulletin explicitly stated that the system would achieve vortex alignment within 24 hours of bulletin issuance. Vortex alignment is the structural change that lets the latent heat feedback loop fully engage. If alignment happens on schedule, intensification proceeds on schedule. If alignment is delayed, the intensification window slides later and may not reach the forecast peak before environmental constraints arrive. By tomorrow's bulletin cycle, the alignment question will be answered and the confidence band on the rest of the forecast will tighten. The second window is the rapid intensification window, Saturday through Sunday. The JTWC forecast explicitly anticipates rapid intensification in this period. If it occurs as forecast, the storm reaches very strong intensity on schedule. If it occurs faster than forecast, the storm could reach very strong intensity 24 hours earlier than projected, with a possible peak intensity higher than the current 950 hectopascal forecast. If it occurs slower than forecast or fails to occur, the storm could arrive at Okinawa at the lower end of the strong intensity range, rather than the middle, with corresponding implications for impact. The third window is the recurvature window, Monday through Tuesday. The current forecast has the storm passing just east of Okinawa, then turning northeastward as it interacts with the synoptic scale steering pattern. If the recurvature happens on schedule, the closest mainland Japan impact is limited to Okinawa and possibly the Amami chain. If the recurvature delays or fails to occur, the storm tracks further west or further north and could make a closer approach to Kyushu, Shikoku, or the Pacific coast of Honshu. The Windy.com summary explicitly named this scenario. Depending on the exact track, the typhoon may move closer to other parts of Japan, especially Kyushu, Shikoku, and Honshu. Each window narrows the cone. Each successive bulletin from JMA, JTWC, ECMWF, and DeepMind GenCast will tighten the forecast envelope. By Sunday afternoon, the storm's intensity at Okinawa landfall will be known with high confidence. By Monday afternoon, the exact track over the next 24 hours will be locked in. The window for population preparation is now. The window for action keeps shrinking. The central question this story lands on does not have a confident answer yet, and it cannot have one. Typhoon Number 6 is forming over a warm pool with full thermal capacity in a year where El Niño onset is shifting the entire tropical Pacific into a configuration historically associated with more intense and more poleward tracking storms. The peer-reviewed literature documents that storms in this basin have been intensifying more, reaching higher peak intensities at higher latitudes, and undergoing rapid intensification more often, for decades now. Each of those statements is documented in operational meteorological products, peer-reviewed climate research, or both. None of them allows the conclusion that the rest of the 2026 Pacific typhoon season will be exceptional. What they allow is the conclusion that the ingredients are in place. The forecast outlooks from the major meteorological agencies, the JTWC, the US Climate Prediction Center, the European Center, and JMA have all projected a more active than climatology Western Pacific season for 2026, citing the same warm pool and El Niño background conditions driving Typhoon Number Six's trajectory. The next 72 hours decide the intensity question. The next 6 months decide the seasonal question. Both are being decided in real time. The storm is real, the forecast is getting worse, and 25 million Japanese people are watching the forecast cone hour by hour as it shifts in the dangerous direction. We will be tracking it through landfall and beyond.